the legs are much thicker than the legs of the ordinary sunglasses because inside the legs of these glasses, the circuitry and a battery. There's another speaker over here. Well, it's about the whole thing, about 46. This is its horn. You can see that the horn has a path to the speaker cavity. It sounds in this direction and then through this cavity, then switch to here. So there must be a certain reflection in this. But the horn is still big enough, the speaker. See, there are three main parts in it. One is a battery part, 110 milliamp battery. There's another one of this kind of speaker with slightly more power. And take a look at this board again. What about this circuit board? Well, a physical button for switching on and off and control the music turns on and off and wake up our AI assistant and answering the phone. It is all controlled by this button. There's another one, this metal shell. This one has a hole in it, just one microphone. Well, most likely it's an analog microphone. And then one of its outputs an analog signal. And then give this, there is an IDC in this to collect this analog signal of the audio microphone. So we give it the audio processing. Well, then what? It also has a low performance one, AMCU processor with an architecture of RISC-V5. After you process the audio signal, go through this DIC again. It is a signal that converts digital into analog, and then give this chip. This chip is a power amplifier. This signal is amplified by a certain power, and then go through this line again. These two are a difference line. A difference line of plus or minus is given to this speaker to drive this speaker. Then this cable of this battery, red and black lines, red and black line, red and black line. One goes to power the entire board. And then what about this one? Well, this one is a ceramic antenna, a wireless connection for this Bluetooth. This volume is very small, so the area is very small. And then there's this part. This is the part, it's two metal touch points. Two metal touch, like this one below. The two metal touch points below this. This metal touch point has a certain elasticity. This metal touch point has a certain elasticity. This is the charging one. Charging this and then through this metal touch point. And then follow this side of the board. What about this side? It's been gilded, make contact with that side for the whole board and for the whole board. And this one charges this battery. Therefore, this cost control is still relatively optimized. Well, spaces like these spaces are not available, not fully utilized. You can be there. You can do some more miniaturization. Look at this. There are no components arranged on these. These are also empty. So this is actually making it small. And this way, well, these are also without components here. Well, you can't put vitality here because there's an antenna down there. So this board is okay. You can make it smaller. And then the whole thing. What about the eyes and legs? You can also make it smaller. No problem at all. And then this battery, the capacity of this battery is still relatively large. 110 milliamp. I put a bigger one. This battery can satisfy the legs of the glasses. If you usually use it, it takes 3 to 4 days. I just listen to music occasionally and occasionally make a phone call. It is completely fine to use it for 3 or 4 days because this battery is placed at the rear. The rear battery has a relatively large capacity battery. It's bigger. What about ordinary Bluetooth headphones? The battery is placed here, put it here. It's just that space is limited, so this battery is not big. So how about battery life? It's not as strong as this one. This one has good sound quality. It mainly depends on one performance. Its SoC is still relatively strong. It's a sensitivity. The sensitivity of AC and DAC is very high. The cost performance is also relatively high. Next, we give it put it on between these two shells. It is fixed directly by means of seizure So it is relatively simple to install and disassemble directly, but there is no glue